Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will simulate a well with slotted liner as a sand control mechanism in Prosper software. All right, now we are in Prosper, so we can click this section. Okay, and then you can follow me. Fluid, oil and water, method black oil. Okay, and then separator, single stage separator, no emulsion, disable PVT warning, and we will use default correlation for the water viscosity, of course, and then viscosity model, we involve Newtonian fluid, and for the well, the flow type tubing flow, well type producer, and no artificial lift. You can also type in the user information, company, field, location, and others in these cells. Okay, and then the calculation type, predict pressure and temperature offshore, in our case, model rough approximation, and full system for the range. And for the brine modeling, we use default. And this is the important thing, well completion, type, case hole, and sand control, we will use slotted liner. Okay, we will use slotted liner as our sand control method. And the reservoir, inflow type single branch, and gas conning no. All right, so we can click done, and we will wait for the system to be ready. All right, wait a moment. All right, now we are ready to input the PVT information, so we can double click. You can follow me. Solution GOR 800 SCF per STB with oil gravity of 37, gas gravity of 0.76, water salinity of 23,000 ppm, no H2S, no CO2, no nitrogen. And for the bubble point, solution GOR, and the oil formation volume factor, we will use Glasso. Okay, whereas for the oil viscosity correlation, we will use Bill et al. Correlation. Okay, and we can leave the other section as default. For example, viscosity, Newtonian fluid, emulsion, no emulsion modeling. And actually, we can perform PVT matching. Like, for example, we have our laboratory data here. We can do matching, but you can watch the PVT matching tutorial in other tutorial in this playlist. For the time being, we will leave it as it is. So we can click cancel. Okay, we will not do PVT matching, but if you want to do PVT matching, that's better. And for the tutorial, you can refer to my other video in this Prosper playlist. All right, we are good enough, so we can click done. All right, from here we can go to IPR data, double click, and for the IPR modeling, we will use Darcy equation. For the mechanical or geometrical skin, we will use Caracas-Tarik model. And for the deviation and partial penetration skin, we will use this method. Okay. And then we can input the reservoir data information. Reservoir pressure of 5,200 psig, reservoir temperature of 210 degrees Fahrenheit, zero water cut, total GOR, automatically populated, compaction permeability no, relative permeability also no. Okay, and then you can see model data, reservoir model, mechanical and geometrical skin, and this is the deviation, partial penetration skin, and lastly we have sand control section. We first go to reservoir model. All right, for the reservoir permeability 50 millidarcies, and then thickness of the reservoir of 100 feet, drainage area we assume 500 acres, with DHF factor of 31.6, we assume a radial reservoir. Wellbore radius 0.354 feet. And you will see this red color will turn to green, right? It means that we are already validated in this reservoir model section. All right, now we go to mechanical and geometrical skin. Reservoir permeability already populated, 50 millidarcies, shot density, 8, perforation diameter 0.43 inches, with the perforation length of, we assume, 9.2 inches. Perforation efficiency 0.9 or 90%. Damage zone thickness, we assume 8. Okay, 8 inches damage zone. So the perforation length is longer than the thickness of the damage zone, with damage zone permeability of half of the reservoir permeability. So if we have reservoir permeability of 50, then the damage zone permeability, we assume half of it. So it will be 25 millidarcies. Crash zone thickness, 12.5. Okay, I mean 0.2 inches. So it will be very, very short, but the permeability is even lower, 12.5. A quarter of the reservoir permeability or half of the damage zone permeability. Shot facing 120 degrees with bore radius already populated. Vertical permeability 5 millidarcies. Okay. All right. Now we go to deviation and partial penetration skin using Chincho and Martin-Browne's method. We assume deviation of 13 degrees with reservoir penetration of 1 as a fraction. So it means that we penetrate all the thickness of the reservoir with vertical permeability of 5 millidarcies. And lastly, the slotted liner itself in sand control section, we will input reservoir thickness of 100 feet, reservoir permeability of 50 millidarcies, production interval 100, right? Because the penetration is 1 as a fraction, we penetrate all the reservoir, so the production interval will be all the thickness of the reservoir. Wellbore radius 0.354, and then liner inner radius, okay? Liner inner radius 0.32, the inner radius of the liner, and the outer radius, of course, 0.34. I mean, of course, it will be bigger than the inner radius. All right. And please be careful here. It's not inner diameter like what we have usually in tubing or casing. Here we have inner radius in Prosper. All right. And for the slot height, 4 inches. You see the height of our slots, and slot width 0.02. With slot density 4 per foot, and then screen outer radius, you can see here the message, only required for screen blank or 0 to ignore. So if we input 0, it means that we will ignore it. Okay, if larger than 0, then must be, let's see, liner inner radius. Okay, in this case we will input 0. Okay, because we don't use sand screen, we use slotted liner with outside permeability 50,000 millidarcies. All right, 50,000 millidarcies. Okay, and then you can see outside beta or turbulence due to material between slotted liner and sand face, 0 to ignore. leave blank to calculate. Okay, let's see if we leave it blank. And now we can press calculate. You can see the turbulence effect is now calculated. This is better, right? Then input it by ourselves. We prefer calculated. Okay, and we already also calculate the absolute open flow, the maximum flow rate. It is 23,245.7 stock tank barrel per day. Okay, so although we have slotted liner here, we have sand control mechanism, but I think the maximum flow rate is still quite high. And we can plot results by clicking this button. I'm interested only in rate and pressure, so I will disable the temperature. Click done. Right, so this is our IPR, pressure in vertical axis, and the rate, of course, in the horizontal axis. We can also plot other, like for example, temperature. All right, so if we increase the flow rate, the flowing temperature will rise. Okay, and then the total skin, remove all first, total skin. Okay, skin increase in proportion to the flow rate. Completion skin also, sand control skin. All right, this is interesting. And then the perforation skin, constant. Damage skin, of course, constant. It's not a function of the flow rate. Penetration skin, deviation skin. All right, so if you sum all the skin factors up, you will have the total skin results. Okay, you can also read the data here and then the results here. Okay, so you can see the AOF, the productivity index is now calculated 7.86. And then the skin, you can see we have skin of 1.58, perforation skin 1.6, and you can see deviation skin is actually negative because we have a deviated well. So if you have deviated well, it will larger the flow path, and that's why you will have negative deviation skin. All right, so we can remove all first and then again plot the pressure. All right, so we are completed in the IPR section. We can click finish. We can click done here and then done. Okay, you can see the IPR here. And now we go to equipment data section. We check the deviation survey. We will edit it. Downhole equipment, geothermal gradient, average heat capacities. We click edit. And you can follow me for the deviation survey. Measure depth 0, 0, and then the next one 600, also 600, and then 1005, 1000 for the true vertical depth or TVD, 4075 for the measured depth, 4000 in TVD, and then the next one 7700 for the measured depth and 7500 for the true vertical depth, 9275 with 9000 TVD. All right, so this is our deviation survey. We can click plot. You can see we have deviation survey or deviated well. We click finish and then done. Okay, now we input the downhole equipment. We will have our Christmas tree at depth of 600 because we have offshore well. And then we have tubing. You can open the drop down. The bottom of the first tubing at 1000 with inside diameter 4.0 52, tubing inside roughness as per default with rate multiplier 1. And then we will have SSSV, subsurface safety valve. Okay, and then the inside diameter 3.72. Okay, rate multiplier still 1. And then we have next tubing. The bottom of it will be at 9,000 feet with the same inside diameter, so I can copy and then paste, and the same inside roughness. Rate multiplier also 1 or 100%. And lastly, of course, we will place the casing from 0, of course, 0, or from this one 600 down to 9275 feet. Inside diameter 6.4 with default inside roughness and rate multiplier of 1. Okay, so far so good. Now we can click done and go to geothermal gradient. First, overall heat transfer coefficient of 8. And then you can follow me. Formation measured depth 0, the temperature 60. And then at depth of 600, 40. And at the depth of the reservoir 9275, the temperature is 210. We can click plot. All right, so this is the formation TVD against the formation temperature. So we can click finish, click done. Lastly, average heat capacities for oil, gas, and water we can use as per default. We can click done. Lastly, you can check the summary. This is for the table. You can also draw downhole. All right, so this is the configuration, the drawing of our downhole equipment. So we have Christmas tree, tubing, safety valve, tubing again, and then lastly we have casing. But in reality, of course, we will have our casing to the top. All right, and this is the depth of our reservoir. So we can click done. So far so good. Done again and done. And we will wait for the picture of our well to be ready. Right, this is the schematic of our well. So from here we are actually ready to perform calculation. And in this case, we will run nodal analysis. So we can go to calculation, system, IPR plus VLP, inflow performance relationship plus vertical lift performance. We can click. And then for the top node pressure or the wellhead pressure, 500. Water cut of 0, automatically populated, but you can edit it. Total GOR of 800, standard cubic feet per stock tank barrel. And then for the vertical lift performance, we can use this equation. I mean this formula, solution node at bottom node, at bottom hole, and then rate method automatic linear, or you can also change the automatic geometry and others as per default. And now we can easily click calculate, show calculating data, very fast. Click OK, and we can click plot. System plot, plot all case. We only have one case. X-axis, of course, liquid rate. Y-axis, of course, VLP pressure and IPR pressure. We can click done. All right, this is our nodal analysis. The orange line is, of course, our IPR, and the pink line is, of course, the VLP. All right. And we can also check the functions, plot view, plot setting, cursor data. You can see the values for the VLP and the IPR, and our operating point is located here. All right. So the flow rate will be 13,600. Okay. And the flowing pressure is around, you can see the number 2,800, right? You can check the value here, 13,800 or 700, and then the flowing pressure of 2,800. And you can also plot other parameters like sand control skin. Okay, again, you can check the cursor value, and then completion skin, and others, of course, as per your requirement. All right, I think we can call it a day. So we have done the nodal analysis in a well with slotted liner as its sand control method. All right, so we can recap. In this video tutorial, we have created a well in Prosper. We have equipped the well with slotted liner as sand control mechanism, and then we model the IPR using Darcy equation, Caracas, and Tarik for the skin method, and then also Chincho, and you can check the Martin bronze for the deviation partial penetration skin. We created the IPR. We also input the information, and then we perform nodal analysis. All right, I think that's all. I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching, and see you again in the next Prosper videos. Thank you.